Hey, 30-1s. Welcome to your first video in transformations. What we're going to look at in this video is we're going to look at translations of functions. So if you can remember back to 20-1, what the word translation means is we're going to move our graphs left and right. So horizontally, we're going to move our graphs up and down vertically. So what we're going to do to begin is grab your graphing calculator. We're going to go back to 20-1 and we're going to look at a very basic function from 20-1 that we dealt with quite a bit, which was x squared. So let's go and graph x squared in y1, and let's go and graph in y2 this new function that I've called g at x minus 3 squared plus 4. What I want you to remember here, or to look at, and then maybe we'll remember, is, okay, how does that vertex change? Okay, let's go take a peek. So grab your graphing calculator and put in those two functions and go ahead and hit graph. Okay, there it is. I'm not quite zoomed normal, but that's okay. So the blue one is x squared, and you see your vertex is at the origin, 0, 0. And the red one is our second function, g at x. And we can see that the vertex is at 3 and 4. Okay, let's go back and look at our functions again. And let's see how we figure that out. How do we remember how to do that? Okay, so here originally our vertex was at the origin. And here our vertex of g at x is at 3, 4. Okay, so let's see if we remember how this goes. If we're translating it horizontally, which is what the x minus 3 is, right? Because it's x, that's left and right, that's horizontal. Remember, when we're inside our parentheses, we go the opposite way. So we went positive 3. And the 4 moved our vertex up and down. So it vertically translated our vertex, and it went up 4. It went the same way. Just like that, friends. What we want to then think about is, well, how does any point change on the graph? So what we do is we say any point is x comma y. And what we did when we transformed it to g at x is we added 3 to all of the x values, and we added 4 to any of the y values. What this is called your map. Okay, so a map is going to make a general rule so you can transform any point. So let's say the point 39 is on f at x. Well, now where is that point on g at x? Well, I'm going to go 3 units to the right. So I'm at 6, and I'm going to go 4 units up. So 9 plus 4. There is my new point on g at x. Okay, and when we go to describe these translations, when you're going to write it out on a test or an assignment, you're not allowed to use any abbreviations. Okay, you have to write it all the way out. So what I would say about this transformation is I would say it's horizontally translated 3 units right. And what I'm going to say is the second one is I'm going to say that it's vertically translated. I can't spell. Let's try that one again. Vertically. Holy cow. I don't have enough coffee in me today. Hey, vertically translated 4 units up. Okay, so there's something that we would have looked at in grade 11, right? Where we would have just had a parabola and we'd say, okay, hey, where is the vertex after I change the form? What is this going to look like in grade 12? Okay, well, in grade 12, what we're going to get is we're going to look at our functions, but they're going to be general functions. So we're just going to call them f at x. So we don't know if that function is x squared, x cubed, is it an absolute value, is it a sine function? We don't know, okay? But when we see f of x, it's a function. It's just a general function. So what do we have here? It says the graph of f of x is transformed to become y is equal to f of x plus 7 minus 8. Describe the transformations and write the mapping rule. Okay, so here's what we have. I'm just going to rewrite it again here. Here is our new function. It's been transformed. So what does this tell me? Okay, inside here, inside the parentheses with the x has to be horizontal because it's x values. So what I'm going to say again, no abbreviations on the test. Okay, on your homework, go right ahead. On your homework, write HT for horizontally translated, but not on a test. No abbreviations. Horizontally translated, 7 units left. Okay, because remember, it goes the opposite way. And then over here, what we've got with the minus 8. So we're going to go vertically translated. Let's see if I can spell it correctly this time. You can see why I'm not an English major, because I can barely print or spell. I'm going to say vertically translated, 8 units down. Okay, so again, no abbreviations, please, on tests, on your diploma, on the written. You can't have an abbreviation or else you won't get full marks on the written question. Okay, what's our map? Well, our map, or sometimes you'll hear people call it an image point. Well, I've gone 7 units left, so that means I'm going to subtract 7. And I've gone 8 units down, so I'm going to subtract 8. Okay, so what I'm hoping you're recognizing is if I was to say there's a trick, I don't really think it's a trick, but you've just got to recognize that what's inside the parentheses here is going the opposite direction. Okay, that's the big thing that sometimes when people are first learning this, they miss. Okay, let's just try one more, my friends, and 2 more, and you'll see, you've pretty much got this. So what do we got? It says the graph of y equals f of x is going to undergo these transformations. I'm going to go 5 right horizontally and vertically 6 up. Okay, let's determine the equation of the transformed function. So what this means is we're going to have a new function, and let's call it maybe g at x. And g at x is what's happened after these transformations to f. Okay, so I've gone 5 right. So that's my horizontal. It's in with my x's. And just remember, I'm going the opposite way in there. So it's x minus 5. And now what I'm going to do is I'm going to go 6 up. So I'm going to go plus 6, like that. Now, don't be surprised every once in a while when you're looking in the textbook if they write the 6 over there, right? Because I can move that across the equal sign to their side by subtracting 6. Okay, I think this is how most of us would prefer to write it, though. Now, write the mapping rule. Okay, map any point x, y. So I'm going to go 5 units right. Well, here's the thing. I'm not going to put minus 5 because my map, I'm going to do exactly as I told, right? Like I'm not going to give someone a map to my house and say, go 5 blocks east when I really meant go 5 blocks west. So I'm going to add 5 and I'm going to go up 6. Okay, so there's how we write our maps. All right, one more to go. The function f of x is equal to x squared plus 2x. So again, it's a parabola from grade 11, is translated horizontally 5 units left and 4 units up. Determine the equation of the transform function. All right, now this question doesn't ask me to describe the transformations, but they're right there for me. And it doesn't ask me to make a map either, but it never hurts to make a map, to think if I had to, where does x, y go and where does it end up? So any point on here, I'm going to go 5 left and I'm going to go 4 up. Okay, so there's our map. But what about the equation, right? What about the equation? So what we're going to do when we're doing the equation is we're going to think of this as replacements. Okay, so what we're going to do is this. We're going to go and say, okay, inside my equation, what I'm going to do is I'm going to say, okay, what does x become? What does y become? Okay. Well, what we're going to do is what we've noticed before. I'm just going to scroll back up here. Is when we're change pen color. Is when we're in our equation right in here, we're going the opposite way, right? So that's what we need to remember when we're doing our replacements. So if I wanted to go 5 units left, I'm going to replace with x plus 5. And if I want to go 4 units up, I'm going to replace y with y minus 4. Okay, let's see what happens. So here's our function right now, and I'm just going to rewrite it as y equals. Okay, I'm going to replace y with y minus 4. I'm going to replace each x with x plus 5. Okay, just like that. And then we're really used to having y isolated, aren't we? So what I'm going to do is I'm just going to add 4 to the other side. And I don't feel the need to distribute and expand this whole thing out. Okay, there is our new equation, just like that. Okay, so again, what I see right here is x has been replaced with x plus 5. So what that means is we've gone 5 left. And this 4 here means I've gone up 4. Okay, so now you're saying to yourself, oh, that's getting a little tricky. How do I check my work? We can't always check our work in this unit, but when we have the entire equation like we do here, we can check our work. Okay, let's grab our graphing calculators, and what I want you to do is I want you to go into y1 and put the original function in y1, and I want you to put our new function in y2, and let's see how we did. So I'm going to hit pause here while you go ahead and do that. Okay, so here's our two functions. Y1 was the original, Y2 is our transformed, and I'm just going to make my window settings normal, so I'm going to go zoom standard 6. Okay, how do I check to see if I did this right? Well, what I'm simply going to do is I'm going to find the vertex of each of these things. Well, I could use my calculator, but I mean, it's that guy right there. Looks like it's at -1, doesn't it? Okay, and this guy over here is 1, 2, 3, 4, 5, 6, -6, and it's 1, 2, 3. Wait a minute. Did we get this question right? Well, we were supposed to go 5 units left. Sure, we did. And we were supposed to go 4 units up. And we sure did. So we can check our work if we have the actual equation. So when you actually have that equation, friends, I want you using the fact that you can pick up your graphing calculator. Now, what you're going to see in your homework is it's going to extend into some different functions. So you're going to start remembering what the absolute value of x looks like, for instance. Okay, so go ahead, play around today with translations. They're making maps, describing the translations, and making the equations. And remember, on a written question, you always write everything out, no abbreviations. See you later, friends.